Hi, welcome to our math. Today I'm doing a series of videos on linear programming. So this process has a lot of steps. The first step is we need to read this story problem and come up with a series of inequalities that represent the situation. Okay, a water supply manager from a Midwestern city needs to supply the city with at least 10 million gallons of potable, drinkable water per day. The supply may be drawn from the local reservoir or from a pipeline to an adjacent town. The local reservoir has a maximum daily yield of 5 million gallons of potable water, and the pipeline has a maximum daily yield of 10 million gallons. By contrast, the pipeline is required to supply a minimum of 6 million gallons per day. The cost for 1 million gallons of reservoir water is $300, and the pipeline water costs $500. All right, how much water should the manager get from each source to minimize daily water costs for the city? Okay, so we will say X is millions of gallons. See, million gallons, each million gallon of water from reservoir. And we'll say Y is million gallons of water from pipeline. Okay, so the first thing we read is that we need to supply at least 10 million gallons of water. So the amount of water that we need from X and Y, X plus Y has to be greater than or equal to 10. It's greater because it's at least 10 million. It can't be 9 million, but it could be 11 million. Okay. Next, it says the local reservoir has a maximum daily yield of 5 million gallons. So the local reservoir, that's X, has to be between 0 and 5. And then it tells us that, by contrast, the pipeline is required to supply a minimum of 6 million gallons per day. So that means minimum of 6 means it has to be between 6 and 10. The pipeline has a maximum daily yield of 10. By contrast, the pipeline is required 6. So that's where we get our 6 and our 10. Okay. So this is really all we need for our basic graph, and then our cost function is going to be $300 per million gallon from this reservoir and $500 per million gallons from the pipeline. Whew. Okay, so that covers the basics. The next thing we need to do is we need to graph this situation. So if I look at X plus Y and I say equals 10, my intercepts, if I set Y equal to 0, X is equal to 10. If I set X equals to 0, Y is equal to 10. And that's our only slant line. So if I come in here and I give myself a basic sketch, 10, 10. This is going to be my first line. Now what it says is that we have to be bigger than this. We're not going to 0 gallons of water. We have to be above this line. So we have to be that way of the line. Okay, next, 0, X has to be 0 to 10, which means here's my 0 line, here's my 10, here's my 5, sorry, 0 to 5. If I put a vertical line at 5, X has to be greater than 0 and less than 5. So now we have this kind of funky position up here. And Y has to be between 6 and 10. So if we put a 6 here and a 10 here, we end up with this funky shape that represents all the different combinations of reservoir, and pipeline water. Now, to actually solve this out, we need to find out what all of these intersection points are. So this one is 0, 10. This one is 5, 10. This one is 5, 6. And this one is, well, if x plus y is 10, is this line, and this line is y equals 6, then x plus 6 is 10 when x is 4. So this point is 4, 6. All right, so we now have the 4 points that define our region. And as complicated as this looked when we read it, it graphed out pretty nicely. The minimum cost is going to come from one of these 4 corners. Even though we have an infinite number of points that satisfy our inequalities, the minimum cost is going to come from one of these 4 points. And so I'm going to test them all out. I'm going to start with 0, 10. And the cost for 0, 10 is 300 times 0 plus 500 times 10, which is going to be $5,000. My next point is 5, 10. The cost is 300 per 5 million gallons from the reservoir plus $500 for each of the 10 million from the pipeline for a total of $6,500. Next, I'm going to come down to 5, 6. Might be obviously cheaper when we drop one of our numbers. I just like to test everything for the symmetry of it all. This one comes out to $4,500. And last, we will do 4, 6. So it's $300 for each of the 4 million gallons from the reservoir plus $500 times 6, which is going to come out to $4,200. So the final answer is the manager should get, let's see, 4 million gallons from the local reservoir and 6 million gallons from the pipeline each day for a cost of $4,200. There we go. We have come up with our equations. We have graphed the inequalities. We have come up with the 4 corners of our feasible region. We tested each of our 4 corners to find the one that minimized our cost. And we wrote our very pretty answer for the situation. Okay, I hope you've enjoyed the video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!